So now that we have defined what EGS is, let's talk about how this technology could impact the energy markets and consumer habits. Terrence, to begin with, tell us where the technology actually is at the moment. Is this system fully operational?
Not quite, Brittany. This technology is still in the middle stages of development. There are currently several active projects in Australia, Germany, France, and the United States, one of which is producing commercial power. The concepts of EGS have been proven to be sound, and the technology only needs to be refined. However, there is still a lot of improvement that is needed. Current test facilities have been able to record fluid flow rates of 10 kilograms per second. This is the flow rate of water that they're able to pump into the injection well and get out of the production well. In order to produce enough power to make this technology feasible, there needs to be mass flow rates between 50 and 100 kilograms per second or higher. In order to accomplish this, the fracturing or cracking of the granite needs to be improved. Due to the nature of the heat transfer between the rock and the water, there needs to be many small cracks created as opposed to a few large ones. This is all complicated by the fact that there is already large public concern about what is called induced seismicity. Induced seismicity is part of the cracking process that creates mini earthquakes. While most geologists generally agree that induced seismicity causes negligible damage to the earth or nature, it can cause minor damage to nearby cities. While the effects may be minimal, it does create public concern, which is voiced through political policies.
So this technology sounds legitimate, but how big of an impact can it have on the energy industry?
Well, according to estimates released in the Massachusetts Institute of Technology report on EGS, there was a potential resource of 13 million quads of energy just in the United States. The annual consumption of energy in the United States is around 100 quads per year, which means that this resource could provide all of our current electricity needs for 130,000 years. This means that EGS has the potential to replace coal, nuclear power, wind power, and solar power as a nearly permanent solution. Since there are nearly no emissions, pollution levels would plummet. It would provide power year-round regardless of weather, politics, or other variables that currently affect energy prices. However, while the potential is high, there are still several hurdles that could limit the amount of potential able to be reached. First is that this resource is currently 4 times more expensive than fossil fuel-generated electricity. There is also the problem of induced seismicity mentioned earlier that either needs to be reduced in the technology or needs to be accepted by the public. Another hurdle is the advancement of this technology. If the problems cannot in fact be solved at all enough for EGS to work, or if the advancements are simply going to involve painfully long and expensive timelines, then this technology might stall or lose consideration in the energy industry. Scientific factors may also play a role in whether or not this technology succeeds. For example, while unforeseen effects of drilling and fracturing techniques are unlikely, they are still a possibility to damage the core of the Earth. Another big detractor will be implementation. Using this resource will involve building hundreds of plants. Reaching full potential will take time and money. It will also include decommissioning hundreds of coal plants and nuclear facilities across the nation. It will destroy a large amount of the mining industry and deeply hurt train transportation. The drilling industry and the EGS development industry will grow, leaving room for birth and growth of many new companies. If EGS is able to reduce the demand of oil, then it will also greatly affect the global political situation, particularly in the Middle East, due to the Middle East having oil as a prime resource. The final barrier is competing technologies. Competing technologies that are cheaper and easier to develop than EGS could make EGS obsolete. For example, if wind or solar power find ways to produce energy at steady rates throughout the year that are cheaper, then EGS might not become competitive.